Hello. In this tutorial, we will take a look at some of the new features in Manifold 5R3, specifically the new manifolds that can be used for warping, etc. We'll start this tutorial by taking a look at a recap of manifolds in general, so beginners can understand the general manifold functionality. Then we'll move on and take a look at the radial manifold. And then finally, we're going to jump into a material and use a lot of warping nodes, along with a host of other node graph functionalities that are part of Manifold 5R3. So it might be a bit of a longer tutorial in the end, just because I'm not just going to show pure functionality, but I'll use it in the context of the workflow. I'll try to provide breakdowns or chapters inside of the description under the video, so you can jump around if it gets too long and too tedious. Let's get started. So let's first quickly go over the existing manifolds in Manifold 5R3. So for example, I have a Manifold UV node and I have a Manifold 3D node. If you're familiar with Maya, you probably know the 2D placement nodes and the 3D placement nodes. This is kind of the same concept. So a Manifold UV processes and modifies UVs, a Manifold 3D processes and modifies 3D world space coordinates. In standard Mari, you have a UV node and a position node. So the UV node outputs UV coordinates of your object, and the position node outputs the 3D space coordinates. If, for example, I create a tiled node, you can see it has a UV input. If I create a cloud node, you have a position input. So this means the cloud node can be evaluated in 3D space, while the tiled node only in UV space. I'm gonna hook up a texture to this, and let's just view this. And inside of the tiled node, you obviously have ways to, for example, change the repeat and the offset. If I attach a UV node, nothing will change because basically the UV node is disconnected. This UV output will default to what this node outputs. If I attach a manifold UV node, which is an extension pack node, I'm also feeding in the UV coordinates. However, on the side of the node, I have also transformation options. The benefit of this is that I can control multiple nodes at the same time. So if I take another image, now I have two nodes with exactly the same tiling controlled by a single node. If I feed a manifold UV into a, for example, cloud node position, then this means that this cloud node is now evaluated in UV space. So if I press 1 to view this, you can see I'm getting the seams where the UV cuts are. If I disconnect this, the position node defaults automatically to the 3D space coordinate or the position. So this is what is mapped to the default port when nothing is connected. If I connect a manifold 3D, I get again the position, but I can also modify the position coordinates. In standard Mari, it's usually named UV and position. However, for extension pack nodes, my naming convention is usually manifold. So for example, if I create an image node, which is the equivalent to the tiled node, but without all the built-in transformations, the port name specifies manifold UV, meaning this one only accepts a manifold UV, or you could also take a UV node, obviously. If I create a cloud extended, which is an extended version of the cloud node coming with extension pack, you can see again you have the manifold name here, indicating that it takes any manifold. So either a UV manifold or a 3D manifold. So you'll see this manifold on a lot of different nodes, and whenever you see it, you can see if a UV or 3D will be accepted, or if it's not specified, it usually accepts both 3D or UV coordinates. So this is the quick recap of existing manifold functionality, and I suggest if you're a node graph user, you should definitely use it because it saves you a lot of time to manually manage all the different tiled nodes and the different tiled transformations or different space transformations for the cloud nodes and other procedurals. With extension pack 5R3, I'm introducing a number of new manifold nodes also designed to transform UV and 3D coordinates. Let's take a look first at a radial transform. So I'm going to create a shape node. And in here, I'm just going to set this to a circular shape and increase the tiling a little bit. And now I want to turn this into a circular pattern. So I'm going to create a Manifold Radial UV. And as the name implies, this node works preferably on UV coordinates. So if I plug this in here, I get immediately a circular pattern. By default, this node will use UV coordinates. However, I can also still create a Manifold UV and hook this up here. And now I can control the repeat of this circular pattern. If I change the repeat inside of the radial UV, I'm instead changing the ring amounts. Now you might notice there's a little bit of an artifact or half a circular shape here that is being cut off. Because it's obviously a 360-degree circle, it needs to fit in all your tiling into different quadrants. There are two options to modify these quadrants. Inside of the radial UV, you have a quadrant calculation. So there you can interpolate the quadrants to kind of create more of a seamless pattern, or the alternative is to make sure that your initial tiling is set to a value that works best with it. So here we have a neatly circular pattern or neat circular pattern. And if I tick on interpolate quadrants, you'll notice it kind of shifts it around a little bit. And if I have an even number, you can see these two elements are very close together. However, if I untick this, it changes the calculation to be quadrant based. So you need to play around with this to find what works best in your context of your object. Now, obviously, I could just create a merge node and create a secondary shape node. And let's hook this up. Set this to multiply. And inside of my shape, I'm just gonna use a disk, for example, to stencil out a pattern. And I can further increase the ring amounts if I like to. And also make other modifications to it. So this way you can create circular patterns quite easily. Next, I'm going to take a look at some of the new warp nodes inside of Extension Pack 5 R3. So I have a simple material here made out of different tiles. I deactivate the displacement for this tutorial because with screen recording on especially, the spin times can get quite high. So we'll deactivate this for now down here in the shader, and we'll turn it on later on. I have a Manifold UV node that controls all my different tiles, and I've gone ahead and also put some bookmark nodes as well as some radio transmitters on different places. So for example, if I use one of the new hotboxes of my Extension Pack 5, so that is on the F8 key, so you can, for example, quickly jump to your different bookmark nodes, or otherwise you can use the right mouse click bookmarks here. So yeah, I've set this up, and let's go ahead, and the first thing we want to do is you want to break up this kind of perfect straight line of the surface. So I'm going to go to my Manifold UV, and the first thing I'm going to do is I'm going to create a Manifold Warp node, which is a new node. So here we have it, and this one uses a grayscale input to kind of displace pixels around. So I'm going to take one of the images from my shelf. I've loaded in these images via the standard Mari shelf, where with Extension Pack 5 R3 there's a bunch of images inside of the shelf. So if I click on one, it'll automatically appear in my image manager. So I'm going to use this one and then just use this for my warping. Open this, and let's increase intensity, and you can see it goes quite crazy and displaces the pixels. Well, the first thing I want to do is obviously I want to probably lower the maximum range that is allowed, just to have some better, finer control on the sliders. You can also see here I have warp input X, Y, Z, meaning I can control the X, Y, and Z axis of warping separately. Two ways to do this. The first thing is you could use an RGBA merge node, which lets you map different inputs to the red, green, blue, and alpha channel. The alpha channel is not used here in the warping. So in this case, you can see my warping is limited to the X axis. Get rid of this again. You can also, inside of the nodes, there's a little S icon next to the sliders. So you enter a channel specific setting, and here you can set the intensity for X to 0. And this way we have a non-uniform kind of warp effect. So I'm gonna go ahead and kind of make smaller adjustments here just to slightly break up the surface a little bit. It doesn't need to be too crazy. So let me copy this value here over. And we have some slight edge chipping. It's very subtle, but it doesn't need to be crazy. And that's actually one thing you want to avoid. You want to have this, you don't want to have this overly warped look, which can easily look fake in CG. So let's backdrop this. So I'm gonna hit again my F6 key, which has this menu mapped to it. I'm just gonna backdrop it. Actually, should have selected my nodes first. Again, backdrop this. I'm gonna name this my material tiling. And next we want to add some kind of dirt effects to this material. So I'm gonna go to my base color, it should be just up here. And let's create a merge node for this. And again, I'm gonna backdrop this as well. And then just call this my dirt over. Actually, one new feature that I'm using the whole time here, which might be very subtle, is when I create a backdrop node with extension pack 5, the colors of each backdrop node will be separate. So if you're using standard Mari, each newly created backdrop will always have the same color. And with extension pack 5, this actually gets randomized. So this is like a little tiny little feature. Anyway, let's create some dirt color first. So I'm just gonna grab another one of my tiled nodes here. And I want to colorize this, and I'm gonna use a color from image, or sorry, a gradient from image. So this will just resample the values based on a provided image. And let me drag in one of these kind of brown textures in here. And actually, let's find some kind of value. I might want to crossfade my tile with just a cloud node, because the tile is obviously also repeating across UV. So if you use this material on a bigger surface, you still have the tiling, even though it's just a very subtle effect. But if you crossfade this with a 3D procedural, for example, the cloud node, then you can have a effect that breaks up the surface more on a global scale across the entire surface and not on a repeating UV-based scale. So I'm going to plug this in here and then just lower the amount. And now we have a bit more value range in here. Also go in here and try and play with this a little bit. Let's see if I can find something that has a bit more variation. And let me adjust some of these gradient image settings till I find something that I like. It has some differences to it. All right. So again, backdrop this. I'm going to call this my dirt color. Actually, just for control, I'm going to add an HSV node after. And let's plug this into our dirt over. And next we need to create obviously a mask to apply this to the base surface. So again, I'm just going to use one of these grunges. Say, for example, I use this one. And let's plug this straight into the mask. And I'm going to jump back to my last used shader. So I'm going to press N and use last shader. And we jump to the full shader evaluation. And obviously this looks like garbage. It's too uniform. So there's no real breakup in between patterns. It's just kind of like superimposed, which is not what we want. So the first thing I want to do is I want to warp this kind of on per brick level. So I'm gonna create a radial node, and I'm just gonna hook this up to one of my brick masks that I've used earlier, and then just use a regular Manifold Warp node and slot this into the tiled node. Oops, sorry, that was actually a mistake. It actually looks quite interesting, but instead of the Manifold UV slot, I should have put it into the warp input. And now I can warp this effect and offset on each brick level. Now, one thing I still don't like here is that the effect kind of still goes uniformly across the surface, even though there's these grooves and everything inside of the bricks. So we'll use the next warp node for this, which is the vector warp. If I create a manifold vector warp and then just have this sort of in this kind of chain, and the manifold vector Warp uses a vector or a normal map to perform its vector calculation. So again, I'm going to create a radio node and hook this up to my normal map that I've already set up before. So if I go to my bookmarks, you can see down here, I have a radio transmitter set up on my normal map. So let's jump back to our base color. And I'm going to plug this normal map into my vector map slot on the vector warp. And then just increase this. And it's going to offset based off the normal map. Now the normal map itself is quite blue, so it's a very neutral color, meaning it doesn't have many slopes. So the effects for the vector normal map, the vector warp, will only be visible really in these strong colored areas. So we have these little grooves and these side edges. So depending on the slope of your normal map, you will get different mileage of this node. So let's kind of play with this. We just have a little bit of an additional effect. It doesn't need to be too strong. It just needs to sit a little bit better on the surface. Now I still don't like really the kind of global effect of this. So the first thing I'm going to do is I'm actually going to swap out the tiled node for a splatter node. I'm going to go to my edit, swap node type, and I'm going to choose one of these splatters, in this case the splatter X1, which uses one image input. Because I've used the swap node type, I'll automatically have the image transferred into this new node. Now obviously this is not what we want, so we need to adjust some settings in this node first. So I'm going to go to my amount and first decrease this a little bit in X and Y. I'm going to go to my input image and also add some edge fall off and edge distortion to this. Increase the size a little bit. I'm going to switch this, for example, to add sub half, just the way the blending is between the cells. And let me see what else we can do here. I obviously need some position offset, so I'm going to randomize the position of this. And let's increase the scale further. Let's add some random rotation to this maybe. And some mask random might work here as well. And there's still a lot of kind of a global effect to this. So maybe we'll switch this to screen. And just play with these settings a little bit. Something like that, maybe. Let's rotate this around. Let's change maybe the noise type in the random noise. Because I want it, but I don't want it everywhere. This obviously looks not that nice at the moment. Let's see what we can get here. Nope, not entirely what I wanted. Let's use a overlay maybe. It's very strong everywhere. So maybe actually this might not be the best idea. Actually, I'm going to try alpha as luminance. That helps a little bit. Let's go back to our warping here. See if we can make this a little bit. Yeah, something like this might work. It's quite noisy at the moment because there's no filtering on the Mari viewport. So let's go into the merge node here and we're actually gonna just lower this to just be very subtle. So it has just some dirt here and there. Now next we want to add some kind of drips. So if you have this as a material and you use it, for example, on a facade, you want to have under the roof some larger drips. So I'm going to add another merge node. And again, I'm going to backdrop this. Call this my drips over. And I'm just going to steal this color chain from the dirt. Let me move this over here. And we're going to backdrop this as well. And I'm going to swap simply the image out. So I'm going to, instead of this kind of soil kind of texture, I'm going to use this instead, and then just maybe play with the cloud instead to have some sort of brownish color. And let's HSV correct this a little bit to make it a bit more something like this. And now we want to create some drip mask that is geometry specific. So the first thing I'm going to create is a directional gradient. So this just creates a gradient along the length of your object. Because I want it black at the top, I'm just going to hit the invert here. And next I want to have some sort of a, kind of a drip effect. Usually for procedural drips I use a Spotify node. So this has all these like interesting features to it. The first thing though, because I'm only interested in these smaller lines, I'm going to invert this. And then go to the transform section and then just pull this up. And let's play with these settings a little bit. And we can always tweak this a little bit further. But I want to use this to warp the effects of the directional gradient. But because it's a directional effect, I'm not going to use a regular warp, but I'm going to use a directional warp for this. So if you go to Manifold Directional Warp, you have this as a new node. So I'm going to plug this into the Manifold 3D of the directional gradient. And this one works by default of the UV coordinates. So in order to switch this back to a 3D coordinate system, as the directional gradient expects, I'm going to create a Manifold 3D for this. And then just hook this into the manifold port of the directional warp. And this way, this one will modify 3D coordinates and feed them into the directional gradient. I'm going to put the invert into the strength of the manifold directional warp. And let's just view the directional gradient. And then just increase the strength. And we can already see something happening, but obviously it's not strong enough. So I'm just going to increase the strength multiplier to have something that looks more like drips. And now we can further adjust the dimensions inside of our Spotify node to kind of get something that looks a bit more like what we would expect it to. See if that one does anything. So if I put this maybe to 150, no, that was not what I had in mind. Let's leave this at 100 and see what we can do with this. Let's move this over a little bit and let's backdrop our previous mask. So this was our dirt mask, because this one's going to be our dirt drips mask. So I'm going to use a brightness lookup to kind of isolate some different areas of this. So the first thing I want to do is right mouse click and invert this. And then let's try and find something that kind of isolate these strips a little bit. Still very regular. So I'm gonna go ahead and actually insert a regular warp node after all. And then just use either a Perlin noise, or I could also use something that is tile based. So let's plug this in and maybe crossfade this with a Perlin. Let's use a Perlin extended because this one has built-in transformation control, so we can save one manifold node. And I'm going to crossfade this here, and obviously it doesn't do anything at the moment because the warp is still at 0. So let me see what we can do here. I only want this warp to work though in Y. So I'm gonna set this to 0. Know how it does much. Increase this a little bit. And then just try to just push these values around a little bit. Let's go back to our curve node. See if we can isolate these strips a little bit better. Might not be entirely possible. Let's view this as part of a shader. So press N, last shader. It's very dirty, obviously. Set this to multiply. Just have a very subtle effect here. One thing I still don't really like is that also these strips do not really follow the bricks themselves. Try and get some cleanup here going. Gonna move this over here, some space. So I'm gonna do the same thing as I did before. I'm gonna pull in a vector warp. So let's create a radial node, hook this up to our normal and plug this into the vector. And then let's just see what we can do with this. So we have some sort of small offset. Back to our shader. And this is the basic structure. So you learned the 3 different warp nodes here. You learned the regular warp, you learned the vector warp and the directional warp. And this is the main structure I'm going to use here. Again, I'm going to backdrop this, call this my drips mask. And one final thing I probably want to do is first I'm going to, no, not yet. I'm not going to activate this placement yet. I want to do one more thing. I want to actually control this mortar a little bit. So I'm going to just add another merge node. I'm going to create a radial node and connect this to my height. Create a brightness lookup. Let's view this. And let me pull down these values and pull this up to make this wider. And then just multiply this over. And let me view this again in a shader context. So now we can kind of lighten and darken this. And finally, let's just turn on the displacement. And here we have it. We have added some dirt to this material. We used all the different warp types to kind of let the dirt sink into the surface a bit more. Finally, let's go to our default objects and then just load another object to evaluate this better. And here we are. So yeah, it works reasonably well. And this is how you work with warp nodes. I hope it's useful and see you next time.